Welcome to Fusion Music. Today we are going to discuss about a topic called materials, metals, and non-metals. So here, this is the basic idea behind how to classify the materials and how to classify the metals and non-metals. So here, basically, the materials are defined as some substance. We may take any example, say for example cloth, or say for example a piece of wood, or say for example a piece of paper. So these are all comes under the category called material, which is used to making or doing something. So for example, by using the wooden piece, we can make a chair or we can make a stool. Like that we can use it for some making some useful substance. So the materials are basically defined as is a substance which is using to do or making something. Say for example, by using the cloth we can make a shade burnt. Like that we can use it for a useful purpose. So such things are called a material. So basically, these materials are classified into four categories. They are metals, polymers, ceramics, and composites. So in this video, we are going to discuss about only about the metals. So how we can identify the metals and the non-metals. So we are going to concentrate on this metals part alone. So this metal alone, we are going to concentrate on this metal part. Okay. These metals are further classified according to the periodic table. So you guys know that about the periodical table is a basic periodical table. So this periodical tables are majorly classified into three categories: metals, non-metals, and metalloids. So first we discuss about that what is the difference between the metals and non-metals. So we can easily say that we come across the different kinds of materials like iron, wood, cloths, thread. Like that we come across the different types of materials. So in that we can easily identify the what is metal and what is non-metal. Say for example, I am giving you some simple examples. We use a iron or a nail. So these are all comes under the metals. Why we call this as a metals? Basically, the metal have a properties like is which have a solids in structure and have a high tensile strength. So these comes under the metals. So basically the metals are the good conductors of heat and electricity, and at the same time it is solid in nature and ductability. So these are all the basic properties of the metals. So with the help of these basic properties of metals, we classify that periodic tables into a metals and non-metals. But non-metals are exactly opposite to that of a metals. So if metals are strong in nature, these non-metals are soft in nature. These metals are good in conductors, conducting the heat and electricity, but these non-metals are not a good conductor of heat and electricity. The metals have a properties of ductability, and these non-metals have a not a properties of ductability. So we'll discuss about the properties like solid, ductability. These kinds of properties we will detail discuss in the next slide. Well, and then third category is the metalloid. So metalloid is nothing but the in-between nature of the metals and non-metals. Sometimes it may be considered as a metal, sometimes it may be not considered as a metal. The intermediate properties between the metals and the non-metals are called metalloids. So that is physically these metalloids are called non-metals, more likely to be non-metals. But certain circumstances, these metalloids can be considered as a metal with the help of the properties like conducting the electricity. So one of the simple example for the metalloids is say for example taking the sodium chloride, which is nothing but a natural salt. So salt is a metal. How we can say that the salt is not able to conduct the electricity as it is, but when the salt is mixed with the water, a salty water can easily conduct the electricity. So under this circumstance, when a salt is dissolved in a water, we consider that salt as a metalloid. So these are the three major categories of metals or classifications of metals with the help of the periodic table. So by come across this periodical table, this is the periodic table. So the left part of the most of the elements are called metals. So there is the red color mentioned elements are called metals, and then the blue color things is the non-metals. So now mostly the non-metals are in gas or liquid in form. The metals are in room temperature, which is a solid in nature. So the metals which are shown in the red color are considered as metals, and the in between structure metalloids are yellow in nature. Say for example arsenic, germanium, silicon, these are all the metalloids. But this silicon, germanium are able to conduct the electricity under the circumstance of when we add a impurity, if we have a free electrons. So like that. So we are considering about the metals. So based on the properties of conductivity, we classify the metals and non-metals and metalloids. Some circumstances, these metalloids can be considered as a metal. So I hope you understand that well about that what is a metal and what is a metalloids and what is non-metals. So now we can go across the properties of metal. So based on the different types of bonding also, we have a properties of metals and non-metals. Say for example, ionic bond and covalent bond. These are the two most chemical bondings in nature. So the ionic bonds, the metals and non-metals are combined to form a ionic components. The non-metals combine with the other non-metals which forms a covalent components. So when we have a covalent components which is strong in nature, so most of the metals have a covalent components only. Most of the non-metals have a ionic component. So here some of the examples for the metals are aluminum, copper, iron, tin, gold, lead. So these are all the some of the examples. When you come across this aluminum, copper, iron, which have a good conductors of heat and electricity, and at the same time which is solid in nature under the room temperature. And these elements have a, so with respect to the Rutherford atom model, we have a neutrons, protons, and the electrons, and the cells are there, K, L, M, N, and cells are also there. So the outermost part of the Rutherford electron model is a valence shell. In valence shell, we have, if we have electrons, we call that as a valence electrons. So these metal have basically across the left part of the periodical table. So in the left part of the periodical table, so according to a periodical table, the arrangement of elements are based on the atom numbers and the valence electrons and the ionization energy levels. So the left part of the most of the elements are low ionization energy. So the ionization energy is the energy which is used to hold the valence electrons. So here for most of the left part of the periodical table, as we seen in that, all the metals are placed in the left part of the periodic table which have a low ionization energy. So because of this low ionization energy, is not able to hold the valence electrons, so it can easily lose the valence electrons, and it is difficult to gain the electrons. So it's not able to attract the electrons from other elements, but it can easily lose the electrons from the valence cells. So because of this property, these metals are a good conductors. So say for example aluminum, copper, these are also good conductors of electricity. So in electricity, the conduction is nothing but a passing the current from one place to another place. So the current have a basic definition of movement of electrons from one place to another place is the basic definition of current. So these parts of these elements, aluminum, coppers, are the good metals which have a low ionization energy. So because of that low ionization energy, the valence electron easily loosed, so it can be moved from, because of the potentials applied to the conductor, it can easily move from one place to another place. So the metals are basically have a good conductors of conduction of electricity and heat because of this property, low ionization energy. Because of this low ionization energy, we have a free electrons. Because of the free electrons, it have a good conductors. But in the case of non-metals, exactly opposite to that of this metals. Since the non-metals, according to when you go with the periodical table, so these non-metals are mostly occurs at the right part of the periodical table, which have a high ionization energy. So I already told that the metals elements in the periodic table are arranged based on the ionization energy, number of valence electrons. Based on that only they arrange from a right to left. So here the right part of the periodic table have a high ionization energy. So these elements are comes across the non-metals. So for these non-metals, because of this high ionization energy, the valence electrons are easily tightly held by the neutrons. So it's not able to lose the electrons. It is difficult to lose the electrons because of the high ionization energy, but it can easily attract the electrons from the low ionization energy elements. So this is the properties of the non-metal. So because of this high ionization energy, which can hold the valence electrons tightly, so it is won't have a free electrons. As I already told that most of the non-metals are gases in liquid in nature. So here some of the examples for non-metals: hydrogen, nitrogen, oxygen, fluorine. These are all comes under the non-metals which won't conduct the heat or electricity, since it won't have a valence free electrons. So these are all the basic difference between the metals and non-metals with respect to the conductivity property. So the conductivity property is nothing but if the elements have a free electrons, it can easily conduct the heat or electricity. But if you won't have free electrons, it's not able to conduct. So the free electrons is based on the ionization energy. So the metal have low ionization, so we have a free electrons, so it easily conduct the heat and water. Sorry, heat and electricity. But in the case of non-metals, it's not easy to have a free electrons since it have a high ionization energy. So some of the properties of metals and non-metals are parallelly we discuss about that. What is the properties of metals and non-metals? Since I already told that the non-metals have the most of the properties of metals exactly opposite to that of the metals. Non-metals have the properties of exactly opposite to that of metals. So the first property we can come across is the malleability. Malleability is nothing but the substance which have the ability to deform under pressure. That is, the shape of the metals or shape of the material can be reformed from one shape to another shape under some pressure. Say for example, if you are able to do an activity, take a piece of nail and hammer it with the force, it deform into a sheet like structure. So the malleability is nothing but the ability to deform under pressure. If you provide some pressure, the metal can able to deform into some other structure. Say for example, aluminum foil. So a sheet of aluminum can be converted into aluminum foil, which can be used for wrapping the food materials. So the metal has the properties of malleability. Malleability is nothing but a one structure is deformed into another structures. But these non-metals won't have a properties of malleability. Say for example, the non-metals like coal, piece, and pencil lead, these are all comes under the non-metals. When you provide a hammer, which is deformed into powder, which is not a metal. So the metal have malleability structure properties, and the non-metals have a non-malleability structure. Take example, a piece of chalk. When you hammer it, it convert into a powder. It's not converted into a metal. But in the case of nail, which is in the form of metals alone. So this is the properties of malleability. Conductivity. Conductivity is nothing but the degree of specific material conducts the electricity or heat. So here when you come across this circuit, here we have a battery. The battery is connected to the bulb through the wire, and in between the two wire we have a nail, which is comes under the metal. So when a metal piece is connected between this red wire and the green wire is connected with a piece of nail, the current continues from this positive sign to the current continues from this the current continues from this positive and travels through this iron pieces, reach the bulb and close it in the negative terminal. So this is the closed circuit. When a closed circuit, the current flows. But in the case of if this nail is replaced with some other charcoal like structure or a piece of chalk, so the piece of chalk won't have a high ionization energy, so it won't have any free electrons, so it's not able to conduct the current. So the metals have the properties of conductivity, and the non-metals have the won't have a properties of conductivity. So these are all the some of the properties of metals and non-metals. Metals have the properties of malleability, and non-metals have the properties of not a malleability. So next thing is the other properties are ductability. Ductability is the ability of the material to change into different shapes. Say for example, we take a bar of copper. The bar of copper is converted into a wire, which is used for connecting the equipments in electrical field. We call that as a wire. Is a wire. In the case of there's a properties of ductability. The example for the ductability materials like copper wire, aluminum wire, and the non-metals are this sulfur, chlorine, and nitrogen. These are all comes under the non-metals. And the fourth property is sonorous. Sonorous is nothing but the metal which can able to ring or which can able to produce sound is the properties of sonorous. So say for example the bell, copper bell or a bronze bell, which are able to when two metals are strike with each other, it can able to produce a sound. So these properties are called sonorous. But in the case of non-metals, it's not a sonorous. Say for example, when you take a chlorine, sodium, so a sulfur powder. So when you have a thing with this sulfur which are not able to produce a sound. The next slide. So conclusions. So from this discussion, sir, we come across this the material which have a hard, lustrous, malleable, ductable, and sonorous, and the good conductors of heat and electricity are considered as metals. Example for metals, as we already discussed, iron, copper, aluminum, calcium, magnesium. So these metals are have the properties of hot at room temperature, solid in nature, and malleable, which can convert from a one shape to another shape. Copper wire, aluminum foil, and which have the properties of ductability, and which have the properties of sonorous, and which have the properties of it can able to conduct the heat and the electricity. But in contrast, the non-metals are soft in nature. It's not sonorous, poor in conduction of heat and electricity. So these materials are comes under the non-metals. Example for the non-metals are coal, sulfur, chalk, chlorine. These are all comes